Okay, hello everybody. Welcome to a new season of stargazing. It's so nice to see so many people here. Not least because it's a clear evening. It's a good omen for the rest of the season, I think, that it's nice and clear. So we have a headline talk from our speaker tomorrow. She's visiting here and she's giving the departmental colloquium tomorrow. She's very kindly offered to give an outreach version of her talk while she's here. And then when we're done, we will lead you out onto the lawn for some stargazing. So to introduce our speaker, we have Enrica Jodice, who is visiting us and is going to tell us all about hidden galaxies and what they tell us about the workings of the universe. So, Enrica.
Thank you very much. And do you hear me? Yes. Yes. Perfect. Perfect. It's a real pleasure for me to be here. As you understand, I'm not English. I come from Italy, and in particular from south of Italy. I'm working at the Observatory of Naples, and here is the view from my office. This is one of the reasons for which in the morning I'm happy to come at work, because there is a wonderful, an amazing landscape on the Gulf of Naples and the Capri Island. Apart from this, I'm also teaching at the University of Caserta, which is a small town close by to around 40 kilometers from Naples, and I'm teaching astronomy there. I'm the pleasure of managing one of the Italian telescopes that is located in Chile, the VRT Survey Telescope, the VST, and the VST is here. This is the small telescope in the middle of the giants. This is the Isocero Paranal Observatory located on the Atacama Desert in Chile. And during my career, I have always tried to understand the physics of galaxies, starting from my PhD, master thesis in physics, and then PhD, and then in the following years. So I have proposed this title, Discovering Galaxies in the Shadow, because recently, during the latest, I would say, 5-6 years, I was triggered by some kind of galaxies. They are very small, they are faint, they are difficult to detect in the universe, and they are reaching a lot of attention by astronomers, because it seems that there is a new class of galaxies in the universe for which we didn't know a lot. I would like to move you in a journey with me. I have imagined that this short talk, not rather a proper scientific talk, but rather like a journey. And I would like to keep you with me during this journey, starting just from here, from the Institute of Astronomy. And first of all, we should move to the site of where we acquired the first observations of such hidden galaxies. And we have to move very far away in the southern hemisphere, in Chile, in the Atacama Desert, and here at Observatory of Cerro Paranal. Here is the platform in the middle of the desert where the 4 very large telescopes plus the VSTs are located. So here we have acquired the first observations. These are the 3 largest telescopes located on this platform. And here is the site where we have the darkest skies in the world. Here is the Milky Way. Here are the two galaxies, satellites galaxies of the Milky Way. We are at more than 2,000 kilometers over the sea level in the Atacama Desert. The nearest city is located to more than 200 kilometers. So this is the darkest place in the universe. And here are located these telescopes where the primary mirror is 8 meters in diameter. And the light from the universe is going this way, is collected on this mirror, and it is then moved to some kind of instruments. The 4 telescopes can also work all together like a 60-meter telescopes. Here there is a view of one of the telescopes from inside of the dome, and these are the instrument. And this is the UT4, and this is the telescope where I personally acquired some of the fantastic images for these low surface brightness galaxies. So let's now imagine that we want to move from the Earth to the universe. Imagine yourself to be on this rocket and try to move from the Earth to the target of the study. The target of the study is a cluster of galaxies, which is millions light year from the Earth. And to reach this target, we have to move from the Earth to our, far from our solar system. Yes, so imagine that we are moving, this is our sun, these are some planets far from the Earth, and we are moving far and far from the Earth. This is the center of the Milky Way, and now we have to also move far from the Milky Way. So we are moving even faster. We want to leave our own galaxies, and here there are the many stars that are inside our Milky Way. And yes, we are almost there. And you can see here is the bright core of the Milky Way. And these are the arms. Our solar system is located in one of the peripheric arms of the galaxy. And here there is. Our galaxies is a beautiful giant spiral galaxies made of a bright central region named the bulge, and with many spiral arms in the outer regions. There are 2 galaxies, smaller galaxies, that are moving around our Milky Way. They are the Magellanic Clouds, and they are named clouds because they just resemble clouds that we see in the sky. They are smaller and they are also fainter. And they are also irregular. This is the Andromeda galaxies with its own satellites. This is another spiral galaxy. This is a nearby galaxies to our own Milky Way. And this is another smaller spiral galaxies that it's located also close by to our Milky Way. But we have to move far away for what is named the local group. The local group is the region of the sky, of the universe, where our Milky Way neighbors are located. So we have to reach another place very far away in the universe. And so we have to push our rocket and move the way. And the universe is appears like this wire. There are these filaments where the brightest dots are all galaxies, and they populate structures that are named cluster of galaxies. And so we arrived on our target. This is the Hydra 1 cluster of galaxies. Hydra 1 is composed by two giants, elliptical galaxies, which are 10 times more extended than our Milky Way. And they dominate the light in the center of the cluster. There are some other spectacular galaxies like this one. What is this? This is a spiral galaxy, like our own Milky Way, but there is something that is happening here. You see, these filaments are made by stars or gas that are moving away from the disk of the galaxies. What's happened? Imagine an hair dryer pushed in front of you, and this huge amount of hot gas that is located in the universe are moving the stars far from the disk of the galaxies. And this is another system. Here is named 1341AB because these are two galaxies just on top of each other along the line of sight. So there is no one galaxy. And look, here there is this strange object, this yellow cloud. What is this? This is a galaxy, and this is an ultra-diffuse galaxy, which is the target of the study that we are doing. This is very faint and has this irregular shape. In the other one cluster, we discovered many of these objects, and this is another kind of ultra-diffuse galaxies. You see that this is something different from the previous one. It's bluish, and this is so faint that these orange points are galaxies behind the galaxy. So the light of these galaxies are just passing through the faintest galaxies that we are studying. And here there are some other objects that are so faint that they are really difficult to detect. And this is the reason why we need the largest telescopes like the VLT, and we need to go to the zero Paranal to detect them. In the universe, there are many, many of these ultra-diffuse galaxies, not only in the Hydra 1 cluster, but also in other clusters of galaxies. And this is one of the most famous, most studied galaxies. This is one of the first discovered ultra-diffuse galaxies. And you see, this is just like a cloud. And it's really hard to study the structure of these galaxies because they are really, really faint. And here is another example. And another one, you see that they might be more elongated, or they might be roundish, or they can be really, really faint. This is the faintest, named nube in Spanish. One of the faintest and largest object detected for ultra-diffuse galaxies. And see also this one. So why astronomers are fascinated by this kind of object? The reason is mainly in the theory for formation of galaxies in the universe. In the theory, the cosmologists have suggested that the universe is not something static. Since its formation after the Big Bang and recombination era, galaxies are moving along filaments. They are attracted each other from gravity, and they start also merging. And merging smaller galaxies that are going to merge each other form giant objects. Giant objects like the two giant galaxies that I showed you before in the center of the Hydra 1 cluster. And they also form larger structures like groups of galaxies, and groups of galaxies start to merge, forming the cluster of galaxies. So there is it's named the bottom-up scenario. It means that from smaller galaxies, like dwarf galaxies that merge each other, start to form larger and larger structures. So the theory predicts a number of these smaller galaxies. And what is seen, don't pay attention to number, but just look at these two figures. Here there is the prediction of such small galaxies, and this is the number of galaxies that we are observing right now. So the question is the theory wrong, or we as astronomers are not yet able to detect the right number of smaller and faintest objects? Because we would need more powerful telescopes with large collecting areas. We have to go into the space to observe such a faint object, or both. We still don't know. We still don't have an answer to these questions. For sure, we have to push further. We have to construct powerful telescopes, as we are doing with the extremely large telescopes that I are going to finalize in Chile on Cerro Amazones. This telescope has a 39 meters primary mirror. So there is a large collecting areas, and so we expect to go deeper and deeper in luminosity for the universe. And then we have also James Webb Telescope that is providing a larger number of fainter and far objects. So this is the reason why we started, let's say, this research field was quite young, I would say less than 10 years ago. We started studying these kind of galaxies. I have already told you that we have used these telescopes, and we have used this really complicated instrument, which is like a spider, and this instrument can collect the light from the galaxy. And these are my braver astronomers, and they are all young guys. Both Marco and Goran. Marco is Italian, Chiara also, and Goran is Chilean. They are all PhD students, so they trusted me to be involved in this research field, and they did very well, and they already obtained the greatest and unexpected results. We asked ourselves 3 questions. First of all, which kind of stars populated the ultra-diffuse galaxies? Are they young? Are they like our own sun, or what? The other thing that it's really interesting, which is the motion of these stars inside. Because, for example, in our Milky Way, we know very well that stars rotated in the disk that it's made by the spiral arms. In the giant elliptical galaxies that I show you in the center of the Hydra 1 clusters, the stars do not have a regular motion, but rather there is a chaotic motion. So we do observe regular motion, chaotic, or what? We don't know. And finally, there are some kind of systems that we we named the compact stellar system. They are made of many, many stars bound to these structures. And this kind of system named globular clusters populate all galaxies, bright galaxies in the universe. So the question is, do we find the globular clusters also in ultra-diffuse galaxies? So the first discovery that we did in our group, and this is the subject of the PhD thesis of Goran, is that it seems that the stars in the ultra-diffuse galaxies are very old, more than our sun, and they started more than 10 million years. So these kind of galaxies are, we can say, ancient objects in the universe. The other thing is that at least half of the galaxies that we observe have regular motion. They rotate faster at larger distance from the center of the galaxies. But there are another half that do not show any motion. They are just chaotic. So this is an indication, at least, that there exist two kinds of ultra-diffuse galaxies. There isn't a unique population of galaxies. And finally, about the compact stellar system, which is the subject of another PhD thesis from Marco Mirabile. These are the whole compact system that we detected in one of these galaxies, and they are made like this, and we discovered many of these. And this is another interesting results, because studying the brightest galaxies in the universe, we know that the number of globular clusters increase with the luminosity of the galaxies. But these are fainter galaxies. So is this a contradiction? Is this a contradiction with respect to what we are observing for brightest galaxies? So all these questions we try to relate the structure and the new results of these galaxies with the formation of these objects. So the question is, how do UDG form? We observed a huge range of observed properties for ultra-diffuse galaxies that cannot fit in a unique formation scenario. So for sure exist many channels that can form in ultra-diffuse galaxies. And have a look at the main formation channels. Astronomers proposed that an ultra-diffuse galaxies might form from a bright spiral galaxy like our own Milky Way that completely lost the gas. The gas is the fluid to form new stars. So for some reason, probably in an effect that I already showed you, no? Interacting with a hot gas in the universe, this shock can remove completely the gas. So the galaxies cannot form new stars, so remain faint and very old. There is another possibility that ultra-diffuse galaxies are just origin from dwarf galaxies, like the Magellanic Clouds that you see before. But they are more extended. So there is a process that just induced a puffed up mechanism. So they are more extended, and as a consequence, they start to be faint and faint. However, there is also a recent scenario proposed for which ultra-diffuse galaxies might form from the gas clumps of the jellyfish galaxies. So the gas just collapses and form new stars and form a new galaxy. You have seen in one of my previous slides that we discovered an ultra-diffuse galaxies in the filaments of the jellyfish galaxies. And so this might be the first detection of these galaxies, because these astronomers made an hypothesis, but they didn't discover an ultra-diffuse galaxies formed in a jellyfish galaxies yet. And finally, in the process that I have talked about the merging of galaxies, there is a possibility that dwarf galaxies and also ultra-diffuse galaxies might form in the tails of the merging galaxy. So you see that all these, you realize that all these scenarios can produce different kind of UDGs, and as a consequence, they have different properties. And so probably the different properties that we observe, in particular in the motion of the stars and also in the content of the content of the globular clusters, might reconcile with the different formation pattern. So it's time to back home here, and so we leave the Hydra 1 cluster and back the journey from that cluster to our own Milky Way and here. And once we are here back, I'm happy to answer all your curiosity and questions, and I hope that I trigger your attention on ultra-diffuse galaxies. Thank you very much.
Thank you so much. Let's get some lights on.
Yes, we are here.
Exciting noises. Do we have any questions for our speaker?
Yes, please.
Not exactly relating to the whole thing, but some people think that wormholes exist. Do you believe this? And is there any actual scientific proof that they do exist?
You repeat your question?
That some people believe that wormholes exist, like places where
What?
Wormholes where you, like, say you're in space, you have a suit on, you fall into like a specific area and you come out another place.
Mm-hmm.
Do you think there are some anomalies like these in space somewhere?
I think that there is a theory. We do not have any evidence for this, at least yet. Yeah, because it's I would say sometimes it's also easy to make a theory, but to prove your theory, you need evidence. Unfortunately, the universe is a special kind of laboratory, because you cannot reproduce your experiment. You just observe what you have, and so you have to reconstruct the history on what you observe. To reconstruct the history,